Excellent. Okay, let's set the scene. So synthetic data generation has often been put across as either a silver bullet or as something awful to be avoided. You often fit in one of the two camps. And the idea of this talk is to tell you that synthetic data is something that we should be using, but we should be using it in the right way, basically. So just to give a very quick example, if we have some ground truth data, this happens to be data which you can't see because it's way too small, which is not the way that you do synthetic data. This is trig points across a hillside. So if we've got some ground truth data, the first step is that we need to make a representative object of that data. So I've used trig point data for a reason, because you often visualize your surface or your landscape in a latent space. I quite like the look of the mountains, but you would need to in some way represent your data. You then need to take that representation and make a simplified version of it, because what we're looking at doing here is balancing the quality of the data, how close it resembles the original data, and the privacy. And by creating that simple model representation, you're trying to create that balance and control that balance, importantly. You then generate data from that. So on this map, you could do a Monte Carlo thing where you're just taking random points. You create a whole new set of trig points, and they should have the same features as your original data, but they don't actually cover your original data. We'll talk about that more. But the last stage is that we then need to evaluate the data back to the generated in terms of its fidelity and its privacy. So if that's setting the scene, let me just tell you a bit more about who we are. The work that I do is trying to connect academia and NHS operations. We work on entirely different timelines with entirely different questions. And the team that I sit in over the past couple of years has been trying to sit in the middle of those and increase the collaboration between academia. We're interested in all these areas, and if you want to talk about any of those afterwards, then I'm very happy to do so. But you can see the third pentagon there, synthetic data and privacy-enhancing technologies. We're aiming to deliver methods for generating and evaluating privacy technologies and for generating synthetic data for the NHS. So what I'm going to talk about here, and I'm going to be going reasonably at pace to try and keep people awake, and also because I've got too much content. I'm going to talk about firstly the fidelity. So this is how close to the ground truth the data is. The different generation techniques which there are, our approach. Then we're going to look at how we evaluate the data, and then hopefully I'll be able to tell you what makes a successful synthetic data project before we finish. Right. Fidelity. The ONS put out a paper, which there's a link to in there, which has this range of different synthetic data fidelity. And it goes all the way from just structural, where you are just taking your metadata for your data set. You're saying, I need a categorical variable and a numeric and a date. It goes up through valid and plausible, where you're starting to say, I need to not have pregnant males in this data set. I need to sample from this sort of a profile, nice Pearson profile, all the way up to the multivariants, where you're starting to say the different variables within my data need to relate to each other. So if you've got this ethnicity, you've got this likelihood of this disease, and we actually need to start capturing those relationships in the data. And as you move forwards, you go from plausible into detailed, and then finally get to replica. Replica is, as it sounds, where you're unable to distinguish the data from the synthetic data from the real data. So what are the use cases of synthetic data? Do not use synthetic data for prediction models, ever. Do not use synthetic data for any patient care, ever. If you want to use synthetic data at its highest fidelity form, then please go to the CRPD in MHRA, and they have a synthetic data service where they not only do some extremely good generation, they do a whole series of checks in terms of how you use the data. So what are the use cases that I'm talking about? Well, I list them here at the bottom. End-to-end software testing. This is key, that we lock our data up, and then we tell people to do innovation and to create architectures that can take, I've heard about OMOPs today, I've heard about fire records, that can take all of these things and build end-to-end pipelines, but we don't give anyone any test data to do that on. So at the most simple level, structural valid data, we need crash test dummies so that we can flow them through our pipeline. Alistair Jones, you may have heard a talk earlier today about artificial data. That's the sort of stuff that fits into there. Tool demonstration. Well, you just sometimes want to show your work. Two of my team in the past couple of days have shown you a geospatial app and have shown you an ambulance simulation, and both of those use fake data or mild synthetic data for tool demonstration. This is the one that I like, faster innovation. And you can see this now expands. It very much depends on what you're trying to do, all the way from structural to replica. Faster innovation, where we're trying to work either internally to build a model, and even internally it can be extremely difficult to get hold of your data, or working with an external company or a consultancy, and they need access to the data whilst they're developing, and they don't want to wait 12 months for your IG access to catch up. Novel linkage. This in particular is patient pathways. I think the NHS lacks patient pathway data. It's a big hole. Longitudinal studies of how a patient's EHR records develops, that's extremely sensitive. If we're able to at least have synthetic data of the right form, that'd be very useful for a whole series of different tasks. Not for taking any inference from it, but for developing. Evaluation of solutions. If someone comes to me with a model and says this gets 99.2% on whatever score, well, that might be because they've trained it on some very idealistic data. If we have synthetic data that we know has edge cases that we've built into it, we're able to actually evaluate the tools that they've got. This little diagram here, this is the assumptions of the base model, and these are the interesting edge cases, and they often don't quite overlap. So the more that we can have data that tests the robustness of the models that were being sold, the better. And addressing bias and quality. A lot of our data has bias and quality in it. If we're able to make de-biased data sets, I'm not suggesting we then go and use those. What I'm suggesting is you look at the end use case with your de-biased and your biased, and you start to get an appreciation for how much that bias is affecting your end use case. Okay, so that's a run through of what I think are really powerful use cases and ones that I would recommend to anyone working in healthcare. Let's have a look at the generation landscape, because when you first come to synthetic data, there's a huge array of different generation techniques. I like to characterize them into 5 different groups. The first one is essentially jittering. This is where you take your data and you add some noise to it, or you generalize. So you take age and you put it into an age band. That's generalization. Or you swap out. You take a rare case and you swap some quality of them so they become an average case. Or you suppress the rare cases. All those sorts of things. That's a really good paper on the review of anonymization techniques that I'd recommend you to look at. The next one is statistical probabilistic models. So this is using something like chi-squared approach or a Bayesian network in order to build up some form of joint probability structure. This is a direct acyclic graph that it's showing. And then you sample in a hierarchical way from that. So you sample from the first circle at the top, the first variable, and then you sample from the next ones and the next ones with joint probabilities. And that starts to encapsulate the relationships between the different variables in your data. That's how the MHRA do their data. So you can see on that link there, CPRD, and also Simulacrum you might have heard of. They both use those approaches. Simulations is one that isn't often talked about, but I do think creating trajectories, or this is a clinical practice guideline, and then running patients through that to generate different events. You're generating completely fake data based off a population. So you put all of your energy into making a really good population and making really good trajectories, and then you sample through it. And Cynthia is an excellent open source repo to look at for that. Perturbations of the manifold is a bit of an odd term, but this is where you essentially are taking that representation, that contour plots that I showed in the first slide, and then you are putting some noise in there. You're either looking at areas where there's not many data points and you're adding points to it, or you're adding some form of a small amount of noise so that you can't tell if the contours are quite going up or down at that point. You've added enough statistical noise to make it undecipherable what the real data was. And then iterative comparisons, which are all the rage. Generative adversarial network scans, which are mostly used for image generation. They're not quite as good as tabular generation, but they're certainly the go-to for images. I've also put on there GPT-3-based architectures. They don't really fit in iterative comparison, but I've run out of space on the slide. But those sorts of things are starting to also make huge amounts of headway, especially around unstructured data. So that's my generation landscape. And I put that up there because I was quite confused when I first came to this. It takes a long time to get your head around it. This is an excellent paper, which you can't see because the whiteboard's in the way. It's the Alan Turing Institute and the Royal Society. And what they've done is they've characterized all these approaches by these sorts of data that you're trying to do. Don't know if you can read it, but they split in structured, unstructured, and then you've got tabular and longitudinal data, image, audio, video. We're mostly interested in tabular data for most of our cases and time series, so we're more looking at those. But a whole series of excellent papers if you want to see the bleeding edge. Right, this is a big industry and people will sell this to us. So at NHS England, we get sold this quite a lot. This is 2021, so it's already 2 years out of date, but these are various vendors, and they reckon it's about 2.1 billion market around the world at the moment. So there's lots of people getting into this. Okay, so what's our approach? Well, I started off a few years ago just trying to get some data out there, and so a project called SynA&E was one of my first forays into this, and this was very much using the jittering generalization and some statistic probabilistic generation approaches. And the idea there was to try and just get a data set out in the public that people could use for testing and training. Not more than that, that's all we wanted. But we wanted to take A&E data and do it. Now, part of this is that we did a big threat model, and we looked at where the different threats would come from. So you've got insiders, so myself, you've got privileged access, people that have another data set that they could link in to your data, and then you've got the general public. And we started to have a look at the connections there. Happy to talk through that separately if you're interested in the threat model. The overall result of that work, however, was it resulted in a low quality data set because the amount of generalization I had to put in there meant that when we added the probabilistic model on top, it was very low quality. It's too low fidelity to be a general use, and it's too generic to be useful for any specific task. That sounds awful, doesn't it? But those data are available online. We do use them for training purposes in NHS England occasionally. Our next foray into it was to say, well, how can we get some better quality than what we did beforehand? And we got a PhD student in called Dom Danks, and he created as a variational autoencoder, which we've called SynthVAE. And you can see the code online at the link there. The variational autoencoder is that one where you take your data, you put an encoder on it, which encodes it down into a representative model. You add a small amount of noise to that model, and then you decode. And so it's a bit like principal component analysis. You brought it down, you've added a bit of noise in there, and then you've expanded again. And you put your training on top of it in order to get as higher fidelity as possible. So the way that we put the noise in there was through a differential privacy mechanism. You'll have to look at the slide afterwards, but that is a standard statistic gradient descent differential privacy module, which you can put in alongside either a VAE or a GAN. So we managed to put that in place, and then our sister team, the NHS AI Lab Skunkworks team, they took it and they did a case study looking at how we could use it. They showed lots of evaluation metrics for it, and they put it into a nice end-to-end pipeline, and you can do that case study online. However, one of the things that we found was this was not good at handling non-Gaussian data. So it handled Gaussian nice smooth profiles quite well, but as soon as we started to have categorical variables which didn't have a nice Gaussian structure, so a big zero length of stay and then a big tail, it's not so good. So how do we do that? Well, in came David Brind in 2022, and he extended the model to include a Gaussian mixture model. And this is essentially where you can take a variable like this, you apply your Gaussian mixture model, and it takes different Gaussian components, puts them all on top of one another, and you can simulate this profile, but in a Gaussian form. And this then allowed our VAE to be able to sample from those appropriately. There's still some issues with that at that point because it was developing. And so we decided to stop at that point, and he then spent the rest of his project looking at fairness. Fairness is another aspect that we're quite keen to investigate. And the trouble is, this is a whole series of different metrics that you can train these different models on for fairness. And the main trouble is that they conflict. You can't satisfy all of these at the same time. You can only ever satisfy one or two at the same time. And so trying to understand exactly what is your fairness metric and how your data set changes as you train on different fairness is an active area of our research, and we're very interested to talk to anyone that's looking at that. But the main idea here is that you would create some form of structural model, and then you would identify a sensitive variable such as gender there, and then you would actually cut the link between them in the structural model. You'd manipulate your data, and then you would put that into your variation autoencoder in order to actually change your data set so that it, you're sort of debiasing your data by aggression. Okay, the final foray into this was that we started to think, how are people actually going to use it? So Harry Weld came along, and he has made this pipeline. This is available at that link, NHS Synth, which is a GitHub repo. It's entirely open code. It's code in the open. We are still developing. The next release will be towards the end of August, but that should give you most of the functionality that's in that diagram. What's that diagram showing you? Well, the green is a data loader, which allows you to put any data set in, and then it loads it into your model architecture in a standardized way. The red is essentially the actual model architectures, and it's made in a way that you can swap in and swap out. So if you don't like our VAE, you can use something else, just pop it in there. And then the purple is a series of evaluation metrics. The orange at the top is visualizations, and the orange that I've not mentioned over here is future work, which I'll speak about in a second. The reason we've put all of this together is that I believe that you don't actually want me to give you a tool which just does it like that. You want me to give you something which you can use and manipulate, that you can start to investigate, if I change the bias, what happens to my data? If I use a different model, what happens to my data? How can I assess the privacy of it? And that's what all of these different modules do. Okay. No idea how I'm doing for time. Apologies. Are we on 5 yet? Okay. Right, evaluating the data. This is a minefield. We heard yesterday about prognosis models and how there is a need to, I'll just do that. Prognosis models, how there is a need to have standardized ways of evaluating, but at the same time, it's really nuanced. It's exactly the same for this, I'm afraid. So let me try and give you an overview of these and the reasons that you might do these different evaluation approaches. Firstly, you want to look at profile comparisons. You want to say, are variable relationships maintained? You'd use a Spearman's rank or similarity matrix to do that. Next, you'd say, are variable profiles consistent? So you'd just have a look at a comparison between two different profiles and then put a statistical test on it, such as a chi-squared test. Detection metrics, you'd actually run your synthetic data and your real data against each other and say, can I actually see the difference between them? You can either use a logistic regression or a support vector machine for that. Next, you want to say, is the range of various data points consistent within my data? And we use propensity scores for that. So this is an example of ducks, where it's essentially saying, do I see this duck in my real and my synthetic data? Do I see this one? Do I see this one? What's the actual difference? So it's a row-by-row comparison. Next, aggregate difference metrics. You want to say how much work is required to align the data points to the expected ones. And there's a variety of different terms in there, but the KL divergence is the most commonly used. And then you might want to visualize your data on a latent space. I'd recommend you don't do that actually, because it's very it looks good, but it doesn't tell you much. The key one to do is this one at the bottom. End use case comparisons and task performance. That's the one to build everything on. You need the others for context, but you need an end use case to test this against. You then need to look at privacy. Privacy, I've talked about anonymization techniques, which I've listed at the top there, but the one which we've started to really be keen on is an adversarial attack. So someone mentioned in a previous talk, could someone do this with my data? They link it. Adversarial attacks try to do that. They try to say, could you link it? Could you invert the model and look at the weights in the model and understand what's going on with my training data? Could you have a look at how likely it is that there is a particular individual in the data, which is membership inference? And we've built a tool actually to look at that, which I'll come to in a second. I just want to also highlight these evaluation frameworks because there's so many different components to this. There's a lot of people trying to make frameworks to help us out, and they're listed there, and we are trying to tie into those at the moment. Okay, Last couple of ones, regulation and law. I don't want to go into this too much, but the main statement is actually this one here. The problem is that regulations in GDPR do not specify which technologies or approaches should be used to meet the standard of anonymisation or pseudonymization. The closest that we've got for this is something called the Working Group WP29, and they put forward something called singling out, linkability, and inference. And if you can show that your data cannot be singled out, linkable, or inferred, you can start to put anonymized data according to that best practice group. But it's still not in law, that. So it's all a bit hazy, which is why we've tried to use these adversarial attacks. So there's a really great one to look at called TAPAS, which is from the Turing, and this is a series of adversarial attacks you can apply to your data. We've created our own, which unfortunately I can't make open because you could use it against us, and yeah, I'm told by cyber not to do that. I also want to flag something called Equitas, which is a fairness package, which gives you this really nice, you can't see it here, but it gives you this really nice fairness tree where it starts to describe different ways of interpreting fairness in your data, and it gives you a fairness report as well, which starts to pick up on which variables and which rows are lacking your fairness. Okay, so I've only got 2 minutes, but what's to care about? I've made these slides for you to look at afterwards. I wasn't expecting to do them. But what to care about is there's 3 main questions that you need to ask. Firstly, what is the right technique to create data suitable for the use case? And very much connecting the use case to the technique is key in this. So you need to know your use case really well. You need to be saying, is synthetic data actually appropriate to use in this? Or quite often, should we just be looking at data linkage instead? Not data linkage, data sharing instead. Sometimes synthetic data is not the most appropriate way to do it, and it's much faster to just do a data sharing agreement. So before you get started, you need to establish, is this actually going to add any value to our work? Okay, you then need to look at how is the data going to be evaluated for its use? Can we actually define acceptable levels of fidelity and privacy, or does no one know? Because if no one knows, you will not get sign off to use that data at the end of the day. You have to get that established at the start. And then how is the data model going to be shared and stored? The reason that I picked that up as a question is, I think this orange box to the right is quite key. Find a use case, understand your data, then do a whole series of DPIAs, because they're really boring. But DPIAs give you something. They allow you to look at first, if I just took my raw data and put it through a DPIA, what's the risk? If I now put it in whatever way the data model is going to be shared, so if it's in an STE or if it's public, what does that do to my DPIA? And then if I replace that with synthetic data, what does that do to my DPIA? And what that gives you is it gives you 3 steps that you can talk to IG with, and you can actually say, you can see the different risk levels for these 3 different settings and how we are mitigating it using the synthetic data. And that then gives you why we're doing it, gives you the levels that you need in your evaluation, and it will actually mean you have a successful project. Unfortunately, DPA is at the start, not at the end, is how you do a synthetic data generation project successfully. Once you've got that, you set your balance of privacy utility, you define your evaluation steps, you put a whole series of benchmarks in, and then you actually generate your data right at the end. Most of the time we do it backwards, that's why. Okay, last slide is the main takeaways from today. I've talked a lot about fidelity and privacy and stuff, but actually you may have heard an undercurrent of the main thing you need to have is explainability. We need to be able to say exactly what we've done to our data, why we think it's got high fidelity, why we've chosen it. And that's why we've created a framework for people to use and make it open, because we need explainability along with it. And we need to be concentrating on our adoption. It's the use case, how are you actually going to use this, what setting are you going to store the data in, because that's all part of the synthetic data generation process. It's not, you don't create the data and then work out how you're going to use it. You need to have adoption at the heart of it as well. So, sorry for the speed, thank you very much.